Good morning, Math 31s. Today we are going to start our applications of derivatives. Our says last chapter for the midterm, but we now know there's no midterm, so that's exciting. Today we're going to talk about intervals of increase and decrease. So we're going to be able to find these algebraically and graphically. Obviously, if we want to do it graphically, we need to know what the graph looks like, and we can actually see where it's increasing and decreasing. So in your notes package you guys have, if you can print them out or just follow along, intervals of increase and decrease, we can see happens from A to B because we can see that our slope here is positive every single time. We can see the y values from A to B are getting greater. So this graph, or the interval where this graph or the function f of x is increasing, is from A to B. We can also see that from C to D, we also have a positive slope, and our y values from C to D are increasing or greater. So we would also say that it is increasing from C to D. Now, decreasing obviously is the opposite of going up, it's going down. And we can see very clearly on our graph from B to C that my graph is going down. So where is it decreasing? From B to C. So that's the easy part when we can see it on a graph. We always read the graph left to right, which makes sense because that's normally how we've been reading our graphs to begin with. So in general, what we can actually say is that the function f of x is said to be increasing on the interval from a to b if for every x value, so this one comes before this one in the interval from a to b, that this y value is less than the second y value. Again, reading the graph from left to right. We can say the opposite, that it is decreasing on the interval from a to b for these x values, this one coming before this one, saying that this y value was greater than the second one. Again, second y value. Again, reading the graph from the left to the right. So when we see this graph, when we're talking about increase and decrease, as I've kind of already alluded to, we are actually going to be comparing the slopes of their tangents. If you look at this graph here, the slope of all of these tangents is positive. And what do we know from here to here? All of these slopes are negative. And so what that means is we can now kind of relate our intervals of increase and decrease to what we did in our last chapter, which was derivatives. And so that is what the next part of your notes is talking about. In general, if we find that the derivative for all the values in that interval are positive or greater than 0, then the function is increasing. So now we don't need a graph. All we need to do is know the slope, which is our first derivative, and we can check using values in our interval to find out if it's positive everywhere. In general, if it's negative, so less than, so we find our derivative and we find values in our interval where it's less than 0, negative values, that is where it's going to be decreasing. So in general, what we have, we're going to create test intervals of increase and decrease. Okay, so you can see that in our intervals of testing for increase and decrease for our values of x, we're going to go back to those interval charts that we had used in pre-calculus, in our chapter pre-calculus. So first example, find the intervals of increase and decrease for f of x is equal to negative 5x plus 4x squared. So the first step that we're going to do is find our general slope, which is f prime. So we know the if I rearrange this and put my 4x squared first, it's nice and easy to see it this way, we are going to get a first derivative of 8x minus 5. Then what we're going to do is find critical values. So we talked about where we can get critical values in our pre-calculus unit, and this is where f prime of x is either going to be equal to 0 or f prime of x is going to be undefined. In this case, because our original equation was a quadratic and our first derivative is linear, we're not going to have any of these. We're not going to have undefined. But we are going to have where this function is equal to 0. So we're going to take that f prime of x and we're going to let it equal to 0 to find our critical values of x. So we get 0 equals 8x minus 5. Move our 5 to the other side and divide by 8. And so we get x is equal to 5/8. And this is our critical value. That is where our graph is probably going to change direction or is going to have some type of break. We know it's going to be a change of direction for this one because there aren't any breaks. There isn't a point where there's going to be something undefined or a point or an asymptote. So what we're going to do for step 3 is create an interval chart. And we're going to see what happens to the left of that 5/8 and to the right of that 5/8. And so all we do is set up our interval chart like we used to. And we're going to have from negative infinity to 5/8. We're going to see what's happening to our slope, which then tells us what's happening to f of x. Then we're going to have from 5/8 to positive infinity. And so once again, we're going to pick a number less than 5/8. Let's say it's 0. And when I plug it back into my value, I get 8 times 0, which is 0, minus 5. So I get negative, so it's decreasing. Then 5/8 to infinity, let's say we pick positive 1. I get 8 minus 5, which is 3, which is positive, and it's increasing. And that's all we have to do to find something that is increasing or decreasing on our graph. So specifically, this one said, where is it increasing? Our final answer would be from negative infinity to 5/8. And where is it decreasing? 5/8 to infinity. And that's all we have to do. So what I want you to try right now is the second one and see if you can first find your first derivative, second, factor to find your critical values, and then third, set up an interval chart. So if you want to just pause the video right now and give that a try, I will finish the example as soon as you guys have given it a try. Working out the kinks, trying to do this for the first time, so bear with me and how awkward this is. Okay, so step 1, finding our first derivative. We're going to get 3x squared plus 12x plus 9. Step 2, find our critical values. We're going to make y prime equal to 0. Again, this is a polynomial, so we know there's no undefined parts. So we're going to get 0 is equal to 3x squared plus 12x plus 9. And then we're going to take out a greatest common factor of 3. And then we're going to factor it. And you can see that we have two critical values, negative 3 and negative 1. And so to set up our interval chart, we're going to go from negative infinity to negative 3, negative 3 to negative 1, and negative 1 to infinity. And we are once again just going to see what happens to y prime and what happens to y. And so when I pick a value less than negative 3, let's say negative 4, this is going to be negative, this is going to be negative, and a negative times a negative is positive, so it's increasing. When I pick a negative number between negative 3 and negative 1, let's say negative 2, I'm going to get a positive and a negative, making this negative, and it's decreasing. Finally, I pick a number greater than negative 1. Maybe let's say we pick 0. We're going to get a positive and a positive in my brackets, so it's increasing. And so for the final answer, when it wants us to describe what is happening for our intervals of increase and decrease, we would say it's increasing from negative infinity to negative 3 and increasing from negative 1 to infinity. And that is all we do for today's lesson. Now you do have a couple more examples that have a few more critical points. I will upload the worked through solutions to the rest of the examples so you can have a look, but I know you don't want to watch this video for half an hour, so I will just post your homework questions that are also in the notes package and in the slides that I will post, and that is it.